Welcome to this skill builder on the t-test. In this session we'll be covering when we can use a t-test. So we'll look at the types of analyses and questions that it's used for, different types of t-test, so one sample, independent samples and paired samples, and we'll briefly cover the assumptions or requirements that need to be met so that we can use a t-test.
A one-sample t-test determines whether a sample mean is statistically different from a known or hypothesized population mean, or a standard value. For example, in the population, the average IQ is 100, and scientists have developed a new drug to make people more intelligent. So they collect a sample of individuals for their study who they'll give the drug to, then each individual in the sample completes an IQ test. Then to see if the drug works, they use a one-sample t-test to compare the mean IQ of their sample with the known population mean of 100. In this example, the null hypothesis would be that there is no difference in IQ between the sample mean and the population mean, and the experimental hypothesis would be that there is a difference between the IQ of the sample mean and the population mean. The one-sample t-test will produce several values including the mean, standard deviation and confidence intervals. It will also give you the t-statistic, which is also referred to as the t-value, as well as the p-value. A larger t-value indicates a larger difference between the sample mean and the hypothesized mean or standard value. The p-value indicates the probability of observing a t-statistic as extreme as the one calculated from your sample if the null hypothesis is true. Typically, if the p-value is below 0.05, the null hypothesis is rejected and the experimental hypothesis is accepted. Before you do a one-sample t-test, there are some assumptions or requirements that your data must meet. These include independence of observations, which means that each observation or measurement should not be influenced by any other. Homogeneity of variance, meaning that the spread of observations around the mean should be approximately equal. And normal distribution, meaning that observations should be centered on the average value, spreading out with decreasing probability in each direction. You can use an independent samples t-test when you want to know if there is a significant difference between two populations. It's used to compare the mean scores of two different samples or conditions. The dependent variable must be quantitative and the independent variable must be categorical. To give you an example, let's say we want to test a new drug that helps people to recover from a certain disease. To do this, we have two groups of individuals. We give one group our new drug and then give the other group a placebo drug. Then we compare the time it takes for the individuals in each group to recover from the disease. In this case, the drug treatment group is the categorical independent variable and the time taken to recover is the quantitative dependent variable. The way that we interpret the significance of an independent samples t-test is similar to what we just covered with the one-sample t-test, except that we are looking at the difference between the means of two samples that we've collected. So a larger t-value indicates a larger difference between the sample means. Again, if the p-value is less than 0.05, the null hypothesis is rejected, and the experimental hypothesis, which states that there is a difference between sample means, is accepted. The assumptions for the independent samples t-test are also very similar to what we covered for the one-sample t-test, with the main distinction being that these are applied to two samples of data that we've collected rather than just one. Also, when we refer to dependence, it's important that the two groups are independent of each other. For example, there must be different individuals in each group, with no individual being in more than one group. The dependent samples t-test compares the mean scores for the same observations on two different occasions. Again, the dependent variable is quantitative and the independent variable is categorical. For example, we might compare students' test results before and after completing a course. In this case, the quantitative dependent variable is test scores and the categorical independent variable is time, so before versus after. So the measurement values are taken from repeated measurements with the same people. Each person or observation has a pair of measurements. A larger t-value indicates a larger difference between the related groups. When we look at the assumptions of the dependent samples t-test compared to other types of t-test, notice that this assumes dependence of observations. This means that each observation or measurement should be related, linked or matched in some way. Also, because we're interested in the difference between each sample, the dependent samples t-test assumes equal variance of the differences between paired observations. We've now covered the basics of 3 different types of t-test: the one-sample t-test, independent samples t-test, and dependent samples t-test. But in some cases, you might want to compare the means of more than 2 samples. For example, you may have 3 or more samples or groups that you want to compare. This can be done using analysis of variance, or an ANOVA. A separate skill builder covers one-way ANOVA if you'd like to learn more. For guidance on the broader range of stats tests, please go to the Skills for Academic Success website at kent.ac.uk/SAS, where you can view more of our numeracy and statistics videos. You can also book a one-to-one appointment with one of the SAS team.